Here is section 2.6, exercise 18. In exercise 18, we're given this conical tank, vertex down, 10 feet across the top and 12 feet deep. Okay. Water is flowing into the tank at a rate of 10 cubic feet per minute. So we're told that the rate of change of the volume is 10 cubic feet per minute. And find the rate of change of the depth of the water when the water is 8 feet deep. Okay, so when H is 8, about 2/3 of the way up, we want to find the rate of change of this thing. Well, so from our example in the text, we're told that the volume of this thing again is, well, what the heck is it? It's pi r squared h over 3. And so if I want to look at dv dt, well, that's that pi over 3, and then times derivative of r squared is 2r, but then remember it's r of t, so dr dt times h, and then plus our r squared times dh dt. And it is dh dt that we want to know. And so to get that, we need to know dv dt, no problem, we have that. We need to know h, no problem, we have that. But then we need to know r to square it and put it here. So r and r squared, yeah, we can probably get that from a little bit of work here. And then, though, we also need dr dt. Okay, so let's go about finding r in terms of h. And so, to make things a little simpler, let's just draw a triangle here where we know that this is 12, this is 5, and that's an angle, so that is a slice of our cone and just half of it. So our radius at the top is 5, the height of the cone is 12, and so then if I go, sort of any other radius and h, any other h, any other triangle, well, these are similar triangles, right? And so what I know is that, I guess you're thinking of tangent, right? Tangent of theta down here is 5 over 12. But what is tangent of theta? Well, it's the radius and it's the height. But that, for any one of these triangles, that cannot change. So for any radius-height combination of this particular tank, I get 5 over 12. And so r in terms of h, r is equal to 5h over 12. And so then I can tell you that dr dt is equal to 5/12 dh dt. Oh, nice. Okay, so I don't actually find dr dt, but I find it in terms of dh dt, which is what I want to solve for anyway. So going back to our volume here, I have dv dt, we'll fill that in, is equal to pi over 3 times, now here I can just write 2r, or I could write it as 2 times 5h over 12. Kind of doesn't matter. I think I'll just do it as r and then substitute the r in. But here it does matter. My dr dt, I need to write that as my 5/12 dh dt, all times h, plus r squared dh dt. Okay, so now I want to fill some things in. Again, I know that dv dt is 10 and h is 8. Okay, so dv dt, I'll write that over here, dv dt is equal to 10. H is 8, but if h is 8, then that means r is 5 times 8 over 12. 8 over 12 is 2/3, so that's 10/3. Okay, so what I have is 10 is equal to pi over 3, 2 times 10/3 times 5/12 times my unknown dh dt, plus, times h, don't forget that, so times 8, and then plus r squared, which would be 100 over 9, times my dh dt. Okay, so I'm going to switch sides with things, but before I do that, I'm going to divide both sides by pi over 3, and so at that point, what I have is, all right, this number. Well, let's see. So the 2, and get rid of that, make that a 6, and so I have and 10 over 6, I could write that as a 5 and a 3. So I have 5 times 5 times 8, that's 25 times 8 or 200 over 9. Okay, so it looks like I have 200 over 9 for this constant times dh dt, plus 100 over 9 dh dt. Well, that's looking convenient. And that's all equal to, remember I divided by the pi over 3, so I get 30 over pi. And so now solving for dh dt, I have dh dt times 300 over 9, which is the same thing as 100 over 3. That equals 30 over pi. And so dividing both sides by 3 over 100, I get that dh dt is equal to, I'll get a 90 over 100, or 9 over 10. 9 over 10 pi. And I think that was in centimeters or so, no, feet. Yeah, so feet per minute. Okay, and there we go. So this one definitely a bit more complicated because we had to do the secondary work. So we had our cone. Okay, we had our cone there with that volume, no problem. We'd seen that before in one of the examples in the text. But they didn't give us all the information about R and H. And I had told you in that first video that we could get R in terms of H or H in terms of R, and we did that using our tangent there. And pretty simple relationship there between R and H. And so we had to use that and do another related rate thing there. Okay, and we plug that all into that original dVdt thing, and after all that messing about, we get 9 over 10 pi, which is, 9 over 31, and so dividing things by 3, this is a little less than 3/10 feet per minute. Okay, so that is number 18.